Welcome to all. I am Beerbal Solanki, Assistant Professor in Ajay Kumar Garg Engineering College, Ghaziabad. Today we recording the basic concept of the Tafl and then its property, basic property. It is the first recording. So we start with the basic introduction. This is the syllabus for the first unit, and this is the objective, course of objective, and then unit, and then objective of the automata. The automata is the basic mathematical model. So here the some important points here we discuss. The automata is the system that performs some basic function without human intervention. The plural of automata is automata. And this is the basic concept. Then we can understand how to use this operate. This is the CPU, and this apply the CPU and give the CPU to by the help of input, and then CPU is process the input data and then generate the output. We use here the program memory, then that is can be RAM or other memory. This is the simple form of numerical method for the basic concept. This is the basic diagram for the automata. Here the input, here store the input and read the input from the input tab, and this is the finite control, and then generate the output, and output can be in the form of shape here. The every automata consists of some essential feature, as in the real output. It has a mechanism for reading input, read from the input tabs, and then the automation can provide the output for some forms if the output is binary, accept or reject by the acceptor, and then output sequence in the response of the input sequence or transducer, and some the automata may have a temporary storage. The most important feature of the automata is the control unit. Here is the finite control unit, and this is the different type of automata: finite automata, push-down automata, Turing machine, linear bounded automata, and other. Now we start the deep knowledge of the Tafl. We understand the some basic concept like the alphabet and strings and language. Then we discuss the first alphabet. What is the alphabet? An alphabet is a finite, non-empty set of symbols. It represented by sigma. So the example of the alphabet, it can be simply non-finite set of symbols. It can be in the form of 0 1 0 1. It is represented by the sigma. So we can write sigma equal to 0 1. If the input alphabet is 0 1, then write like that. If the input alphabet is AB, then it can be write as sigma equal to bracket mein AB, like that. Example here, sigma equal to 0 1 is a binary alphabet, and sigma equal to 0 1 2 3 4 9, it is a decimal alphabet. It can be also, and sigma equal to ABC, and like C to Z, it is a lowercase alphabet. It generally represented in the small alphabet or numbers like a binary number or decimal number. So now discuss the next things is that string or words. A string or word is a finite sequence of symbols over the sigma. Sigma is the alphabet. So string, how to define the string? Example, string like that 0 1 0 0 110 is a string over the input alphabet. If the input alphabet like the sigma equal to AB, so it can be string can be write in the form of for the language simple A, B, B, C, B A, double B, double B string. It is the string defined over the alphabet AB. So is the simple example for the strings. Now common term is the next term, that is length of the string or power of sigma. The power of sigma, how to define it, is the most important feature, that is sigma k. Sigma k is the set of the strings length k. इसमें जो हमें बताया गया है कि W की जो स्ट्रिंग की लेंथ होगी वो आपकी किस पर डिपेंड करेगी? It is represented by the here k symbol. So here a sigma, if sigma equal to 0, तो ये आपकी की एम्प्टी लेंथ की एप्सिलॉन लेंथ स्ट्रिंग, it is represented also here, it is called epsilon, means sigma. इसमें जो भी है अपना कोई भी सिंबल एग्जिस्ट नहीं कर रहा है, तो इसको एप्सिलॉन बोलेंगे, या इसको नल से भी रिप्रेजेंट किया जाता है, जिसकी इसको नल से या एप्सिलॉन से, दो चीजें हैं, जो सिग्मा लेंथ की 0 है. And then if the sigma equal to AB, then it can be for the length A1, so sigma equal to 1. Here length या तो A, it is either A or either B. If the length of sigma 2, that means double A, double B, BA, double B, it can write. And then if the sigma length is 3, then it can be write as triple A, triple V, A double B, double A, B, A, AVA, BAV, like that. So here sigma power, it represent the length of the string. So next is the reverse of string. How to find reverse of string, or how to represent the reverse of the string? W is represented as W power R. If the W means string is XYZ, then the reverse of that string is represented by W to the power R equal to reverse of this. So this can be write as Z, Y and X. Simply the substituting of the string, if W is a XYZ length string, then its substring R, it can be defined as sigma. It can be sigma, it can be X, Y, Z, XY, YZ, ZX, or it is also a XYZ. So how to represent the substring of a string like that. Now the common term is prefix of a string. So the prefix of a string can be defined as like, if suppose W is a string XYZ, then its prefix R, it can be epsilon, it can be x, it can be xy, also it can x, y and z. So it is the prefix of given string w equal to x, y, z. Now the suffix of string, if w is a string in the form of x, y, z, then its suffix is r. It can be null, it can be null epsilon, it can be z, it can be y, z, or it can be x, y, z. So now the what is the meaning of language? A set of string over sigma is called a language. Here, how to define? Suppose w is a string that contain alphabet 0 and 1, and w has a equal number of 0 and equal number of 1. तो ये आपका किस तरीके से, ये आपको इस तरीके से बता सकते हैं कि इसमें जो w जो स्ट्रिंग होगी उसमें जो आपके सेट होंगे, सेट ऑफ स्ट्रिंग्स होंगे, उसमें नंबर ऑफ 0 एंड 1s आपके क्या होंगे, इक्वल होंगे. लाइक दैट 0 1 and 1 0, 0 0 1 1, 0 and 1, 0 and 1, and 0 1 1 0. It means that, like soon, it means that if the number of a is 1 and then number of 0 is also 1. If the number of zeros is 2, then number of ones also 2. If the number of ones is 3, then number of 0 is 3 also. So the language 1 is w has a equal number of ones and zeros. So the string is that. String is what for the language? 0 1 1 0 0 0 1 1, 0 1 0 1 0 1 1 0 1 0 is like that. And also the and another language is defined as w equal to ab closure, and the length of the string is absolute value less than equal to 3. इसका कॉम्बिनेशन कोई भी हो सकता है. इसका मीन है ए बी का कोई भी कॉम्बिनेशन, इसमें आपकी लेंथ मैक्सिमम एट मोस्ट द लेंथ ऑफ द स्ट्रिंग is equal to 3 or less than 3. So the it accept the string like the epsilon. It can be epsilon because it is represent closure. It's a 0, it's 1 0 0 0 1 1 0. It's the all combination. So the maximum length of this, it can be 3 alphabet 1 1 1. तो ये आपका represent how to represent the language in the form of the string. Language is a set of strings. Now we define the clean closure. It is the a very important terminology using in the Tafl. Clean closure represented as a sigma star. Clean closure is represented as a sigma star. Sigma to the power. It's a set of string of all possible sigma star equal to sigma star equal to sigma 0 length union sigma length 1 and sigma length 2. It means that the alphabet of the string, it can be contain 0 length string, it contain string length 1, it contain length 2, it contain length 3 and so on. It the all union. It the 0 length string, 1 length string, 2 length string, it is the union of all the strings. So the clean closure represented like that. It is a accept the all type of the string that contain 0 length, length 1 of string, length 2 of string, like that. If sigma equal to AB, AB is the alphabet, then sigma star, it means the clean closure of sigma, it can be represented 0 length in epsilon A, V, double A, B, V, A, B, it can be infinite. So, now discuss the next point is that positive closure. Positive closure represented as a sigma plus. It means that here can be see, you can see here sigma power 1. It means that it does not contain the epsilon alphabet or alphabet. So the positive closure represented as a sigma star is a set of string of all the possible length. इसका मीनिंग ये हुआ कि सिग्मा पॉजिटिव क्लोजर का मीनिंग ये हुआ कि इसमें सारी जो भी क्लीन क्लोजर की जो भी स्ट्रिंग्स हैं उनको एक्सेप्ट करता है, जिसमें एक्सेप्ट किसको, एक्सेप्ट जीरो लेंथ जो आपका क्लीन क्लोजर है, क्लीन क्लोजर में एप्सिलॉन आता है, एप्सिलॉन, तो इसके एक्सेप्ट इसको क्या करेंगे, एक्सक्लूड कर देंगे और सारी जितनी भी स्ट्रिंग की लेंथ होंगी उनको क्या करेंगे, इसमें हम कंसीडर करके चलेंगे. तो इसमें हमें लिखा हुआ है कि सिग्मा पॉजिटिव क्लोजर रिप्रेजेंट हियर, दिस इज द पॉजिटिव क्लोजर. It means that it contains the 1 length string and 2 length string and also 3 length and 4 length, 5th length and so on. It can be write as the clean closure equal to union of 0 length union positive closure. It represent epsilon. So we consider for the clean closure 0 length and positive closure for the clean closure. Suppose sigma is the alphabet that contain the A and V alphabet, then the positive closure of that can be write as sigma positive closure that contain A string, B double A double B A B B A B double B triple A double A B and so on, like can be write as A double V triple V double V A and so on. So this is the positive closure, and here the difference between the clean closure and the positive closure. If we write here positive closure include equal to clean closure minus 0 length string. So here can be write the relation between the positive closure and the positive closure equal to clean closure minus sigma power length 0. So we will discuss the next things I think in the next lecture, like the finite automata and this is the structure for the finite automata we will discuss, and then we will discuss the now discuss the application automata. The application of automata like the string matching. Suppose number of string is exist for the language, so how to which language accept the string, so we can accepting the string to the language, then we use like a application string matching. And lexical analysis useful in the compiler design, so it is helpful for the compile design subject. And then the design and analysis of the digital circuit. So the automata can be used for the digital circuit to design the different types of the circuit, and analysis of the different types of the circuit. It also helpful for that purpose. So the next we discuss the finite automata, deterministic finite automata, and the non-deterministic finite automata. This will be discussed in the deeply in the next lecture. So the simple. Now we resume the this is the daily question. This is the objective type questions for the Tafl. One is the first is the one language can be expressed by more than one FA, the true or false, and can be defined as simulated NFA. And then third question, fourth question, and then the daily questions quiz, and then finite automata with output, and then here this is the references, and then